Hi everyone! Welcome to Pandemic Python Teaching and Coding in Place. This talk is about my experience as a volunteer teacher as part of a massive and global online and free course about Python. I'll be discussing some of the successes of this massive and open online course that can be useful for those who love to share their knowledge about Python with others. I will also be sharing art historical images of snakes. Just to introduce myself, I'm Lisa Taliaferri. I am an educator and researcher. I did my PhD at the City University of New York, and I have held research appointments at MIT and Harvard. I wrote a popular free and open access book on how to code in Python. It's been downloaded over 140,000 times. I'm currently managing the developer education team at DigitalOcean, where we work together on learning resources for the global developer community. Like many, some parts of my life changed due to the COVID-19 pandemic, and something that helped me keep the bigger picture in perspective and engage with a larger community was my teaching Python as part of Code in Place. So learning online is hard, even in a field like computer science, and even in particular with Python programming. Even though there are so many free resources about these topics available for free and online, it is still not an easy task to learn something deeply without collaboration. This collaboration often takes place in person, whether it's in classrooms, at community centers, or at hackathons. Learning during a global pandemic is even harder. All learning must be done online because gatherings cannot take place, and there is additional stress and shifting and challenging life situations. So, is it possible to replicate a collaborative environment online and build a community to drive human connection over a shared learning goal during a global pandemic? Having a guide, a roadmap, and a support system can help. Two Stanford University professors, Marin Sahami and Chris Peach, decided to create a service-oriented online coding class alongside a traditional Stanford University course. Instead of going a whole term, this course would be half the term. As Chris writes in this tweet, the course was led by many volunteer teachers, with one teacher for about every 10 students. This 5-week-long course would begin on April 13th, 2020. The major goal of Code in Place was to learn how to solve problems with Python. Both learners and teachers had to apply to be involved. Students who were part of the course were expected to be beginners, but they were asked to solve some entry-level problems in Python through some preliminary self-study in order to join the course. The learners were expected to spend 15 to 20 hours a week on course materials, lectures, seminars, things like this, and self-study. Teachers also had to fill out a form and send in a 5-minute teaching demo based off of a Python lesson plan. This here is a screenshot of my teaching demo, which involved calculating how much my cat would weigh on the moon. I decided to join this class as a section leader because I was very intrigued by the experiment. I knew that retention rates were low in massive open online courses, also known as MOOCs, and I had never heard of such an enormous course like this being offered with a 1-to-10 teacher to student ratio. Also, the global scale of a course like this was unlike anything I have heard of before. As a volunteer teacher, I was expected to spend 40 minutes a week or so leading a study session with about 10 learners at a set time. I also attended a couple of training sessions and kept track of where students were in their studies of Python by paying attention to the lectures, the lesson plans, and the discussion boards. So Code in Place is based off of this course CS 106A, Programming Methodologies. This is a term-long course. It starts with control flow. It finishes up with list and dictionary comprehensions. And there are sprinklings of how the internet works, how to use Python for artificial intelligence, and things like that. The course has lectures generally led by 2 professors alternating. There are sections led by teaching assistants. There are assignments for students to complete and diagnostics to check on their progress throughout. And these are intentionally called diagnostics rather than exams. Something that I learned as part of Code in Place was that there is a special component at Stanford University courses, and this is Carol, a robot that teaches functional algorithmic logic via its own graphical IDE designed specifically for beginners. Code in Place is very similar to CS 106A. It follows the similar format with 2 professors giving lectures. In this case, they are pre-recorded video lectures. There are section leaders that are holding live sections. In this case, they are distributed video sections at a specific time to accommodate all of the time zones involved. There are assignments, there are diagnostics, and there are projects. Just like in CS 106A, the sessions start with Carol, who teaches the fundamentals of algorithmic logic and control flow. And it ends with data structures, though there is this graphics section sprinkled in. So generally, the Code in Place curriculum tracks to the first half of CS 106A. What was remarkably different about Code in Place than its text of a course was the scale of the course. In Code in Place, there were 10,000 learners and 905 volunteer teachers section leading once a week. Of the cohort of students that was eventually selected, there were 80,000 potential students who perused the programming problems. There were 40,000 potential students who finished those problems. Then there were 20,000 students who submitted the applications after they finished these problems. Students were selected for their time availability and their current programming ability. Students were not expected to know how to code, so those who seemed to do the problems too quickly were not accepted as this was a beginner course. There were 12,000 folks who applied to be section leaders and the 905 who were selected based on their demos. In my section, I had 11 learners working through Python. These folks were based in North America, Europe, and Africa. The Code in Place community was spread throughout 6 continents, and they are in every time zone. Almost every country is represented in this map. You could see that anything that's in blue had at least one member of the Code in Place community involved. Any country that is in gray did not have a representative. The global spread of the teachers alone is represented in this map. As you see, there is also a distribution across all of the time zones. The section leaders hailed from both academia and industry, and each of these section leaders provided students with a unique perspective. My background of working on digital humanities research resonated with folks who were multidisciplinary, who were looking to change jobs, or those who had studied the humanities previously. I also have some industry context, so I could help those folks who are thinking about changing careers. So what did we learn in this course? We started with Carol the robot, and then we moved on to control flow in Python with programs like Magic 8 Ball simulations. Here is an example of that Magic 8 Ball. We have a while loop, we have if statements, we take in input from the user so that we can randomly provide one of these Magic 8 Ball answers. Where did we get to? We ended with some stretch goals in data science, including tracking COVID-19 cases through data from Johns Hopkins University that was given at the time we went through the course. In this example program, students loaded values from a text file into a list. They counted the number of non-zero values in the file. This is days since the first case. And they created a list which stores how many new cases there were each day to count the increase in cases over time. In this example, we have an Italy text file, but we provided text files for every country that was reporting data so that students could really dig into this. And this might be a basis for their final project, which was entirely open to them to decide what it was about. How did we learn these things? We used a lot of different tools to learn. There were the pre-recorded lectures that I mentioned. Assignments were distributed via PDF. Sample code was distributed via zip files. There were these video-based section meetings. People used different tools. A lot of folks use Zoom, and that's what I personally did. There was an ED discussion board. This is a learning management system. Within the discussion boards were interactive consoles. The diagnostics were automatically graded computationally so that students could self-assess where they were, and everybody was using some kind of an IDE. PyCharm was the universally used one, but some students and teachers opted to use alternate IDEs. So the two things that I think were really working well in Code in Place and set it apart from some other distributed and online courses were the live sections and the discussion boards. So sections generally followed this format that I have written out on the slide here, and this is basically what was recommended among the teachers. So starting with an icebreaker, I would usually opt for Think, Pair, Share, which is my favorite pedagogical tool, where you have an open-ended question. You ask the learners to write down a response, to share it in a smaller group, and then to share it again with a bigger group. I used breakout rooms for this purpose, and it worked much better than I was expecting. Next, we would go into space for questions about the lecture, about where students were in their Python learning experience. Was there anything that was blocking them? Next, we looked at a code problem together. This code problem was distributed to everybody ahead of time because this is an entirely volunteer course. Some students did not have time to look at it before our section, and that was totally fine. We would go again into breakout rooms. Students would work together to collaborate on the problem. I would always join a breakout room myself. And then after we had some time to collaborate on this, we would go together, live code the solution, I might share my screen, students might share my screen, their own screens, but in any case, the students who are driving this, I would purposefully put in some mistakes. I would ask questions to see what they were thinking. We would go through like alternative solutions to the same problem, and then kind of discuss like what was the most efficient and graceful solution. Next, we would discuss any questions about the section or about what's coming up next. And once we were all done, I would go onto the discussion board and share our final solutions and invite students to share alternative solutions if I did not catch all of them. The discussion board. So we used Ed, as I mentioned, and there were several different boards that each member of Code in Place had access to. There was a large group board, so 10,000 students, 905 section leaders, faculty members, and other folks helping the course, like over 11,000 people all together on this group board. Not very private, but closed off to this group. But anybody who had a question or wanted to create conversation, they would be able to get responses right away. It was very, very lively. Others could just read through the threads and learn something, even if they did not feel comfortable participating in this big group. There was a teaching only board limited to the section leaders. This was a place where teachers could exchange knowledge. There was also a small teaching cohort. So those training sessions that I mentioned, we had about 40 people all together there. This was a more intimate space for us to share knowledge without kind of blasting it to the bigger teaching group. Finally, there were section limited boards. These boards would be only the folks in the section leader. In my case, there were 12 of us, the 11 learners and me, and this was a space where those of us who had already built a rapport could share information, could ask questions without having to feel embarrassed and asking a very large group. Finally, something that I think was really effective about these discussion boards were that there were interactive Python and Carol consoles, and I'm going to show a video of what that looked like. So here we see a dog-years.py program that calculates dog years. You run the program right in the discussion board. You could put in user input, and then you'll get the return result that you expect. This was interesting to me because students could edit the code that I shared. They could run it. They don't have to open up a separate IDE. I thought this was much more impactful than just putting in like a Python like markdown that students can't interact with. And I use this tool a lot. So another thing that I think was special about Code in Place was just the demographics and the representation. If we look at the demographics of Stanford University in the computer science department in particular, we have gender on the bottom left, race on the bottom right. So for the 2018 to 2019 autumn quarter, the total male student population, including undergrad and graduate students, was 960, and the total female student population was 444. If you look at the race breakdown, and this data is from 2015, most Stanford computer science majors are Asian. That combines the East Asian and South Asian data, followed by white, which makes up 38%, Hispanic 9.5%, and Black 6.1%. The top right corner is an age distribution. This is for the entire Stanford student population, so not exclusive to the computer science department, and inclusive of undergraduate and graduate students. We see that those who are in their 20s are very well represented in this data, and those who are 35 and over only make up 4.9% of the total student population. Something you might expect from traditional universities. If we look at the gender and diversity at major tech companies, we see that men are very well represented as employees in that space. Underrepresented women of color are exceptionally underrepresented, and here by underrepresented women of color, we're talking about those who are Black, Latinx, Indigenous, or mixed race. We see that cohort of underrepresented women of color do not track to the population of the United States, which is what this data in particular is about. So we do know that we have a long way to go in terms of inclusion and diversity in the tech industry. So how does Code in Place compare? So the student cohort of Code in Place was pretty much at gender parity. 47.5% of the students identified as men, 49.7% identified as women, and 2.8% identified as non-binary. We looked before at the map and saw how distributed the students and also the instructors were coming from all over the world. Some countries better represented than others. Something else that I thought was really interesting though was the age distribution of those who were students at Code in Place. So the 20s are very well represented again, but there is a lot more activity in the 40 plus cohort, and I think that this brings greater kind of life experiences and like different ways of exchanging with folks and learning from people's previous careers, something that is often not in a traditional computer science university course. For my section, I was, as the teacher, was definitely the youngest person in the Zoom room. I thought it was really informative for me. I learned a lot from my students, and this was something that was very special that I don't usually get to be a part of. So those are the demographics, but why is it that Code in Place was able to be so inclusive? There were a few different reasons. One, it was extremely open. It was open to anyone who was over 18. It was open to people who had the time and inclination, and it was open to people with an internet connection. Admittedly, the internet connection piece is still a barrier to entry for many in the world, but there was no gatekeeping about degrees. There was no gatekeeping about assumed computer science knowledge. So this created a much more open space, and we were able to draw from a bigger cohort of students. Second, there were clear expectations about the course from the onset. The class was just for fun. If you learned something, you have been successful. There was the emphasis that the teachers were volunteers, and to be, to think about them as people, to understand that we're in a global pandemic, and to give everybody like time and generosity. Third, there were class values that were communicated from the beginning of the course. One was that the art of computer science, like computer science is not just a science, but also an art. Second, learning by doing, not just receiving information, but actively participating in your learning, trying things out. Third, being humane in trying times. This was important as a way to ground the course within this pandemic. Gratitude, which I mentioned before, being grateful for the free course, being grateful for the community and all of these opportunities for exchange. Finally, there's being welcoming, working to bring people in rather than cast them away. Finally, another thing that I think was really useful was the grounding of programming in real world examples. So how are people using Python in art, like at Pixar? How are people using Python to innovate in the medical field? How are people using Python in business? How are they creating points of sale applications and things like that? The sections which I mentioned before, I think also provided a bit of the human touch. There were the icebreakers, the personal stories, getting to know each other, holding space for questions, having people coming from both industry and academia to unite in this common mission and learning together. This provided some kind of semblance of normalcy as well as routine during an otherwise challenging time for a lot of folks. So I'm just going to share some of the final data points about Code in Place. Again, 905 section leaders or teachers, 10,000 learners. What was so wonderful about this course was that there was a 15-time retention rate versus a baseline MOOC. So that's those sections with the structured and accountability, the structured and community, I think really did a lot to drive that retention. After the first section, 99% of students wanted more. They didn't want to stop after that. Altogether, there were 6,000 hours of live teaching and 60,000 hours of lecture watching. So just to leave you with some parting words, I think that Code in Place was not only a worthwhile experiment, but in my opinion was also hugely successful. For those of us who teach Python, whether it's in the classroom or whether it's through hackathons, community workshops, I hope that we can also follow this humane and community-focused approach to share our love of programming with new learners. Thank you so much.